Good morning students, this is Swati Pisar and today I am going to start the section 2nd of the 12th standard physics. First of all, I shortly introduced the contents of the section 2nd. There are total 10 topics in the section 2nd, starting from the wave optics, and the last chapter is semiconductor devices. Out of these 10 topics, you are familiar with the wave optics, electrostatic, current electricity, then magnetic materials, means the concepts of magnetism, and the last topic, which is semiconductor devices. The rest of the topics are new to you. So, in the today's lecture, we are going to start the 7th chapter of your syllabus and the first topic from the section 2nd, which is the wave optics. Wave is the fastest mode of transfer of energy, and optics, this word is related to the light in physics. Okay, there are two types of the optics. The first is the geometrical optics and the second is the wave optics. Geometrical optics we have seen in the 11th standard while studying the reflection and refraction of light rays through the reflecting surface. Again, the reflection and refraction through the lenses, mirrors, etc. We have already studied the lens maker's equation, prism formula, then total internal reflection of a light. All these concepts belongs to the geometrical optics. And in the 12th standard, we are going to study the wave optics. Okay. Now, I'll introduce some of the basic concepts which we are needed in the topic. The introductory part. हा पार्ट तुम्हाला थिअरी मध्ये विचारला जाणार नाही, पण टॉपिक सुरू करण्याच्या आधी आपल्याला ह्या गोष्टी माहिती असायला पाहिजे. सो द फर्स्ट फिगर एक्सप्लेन्स द रिफ्लेक्शन ऑफ अ लाईट and the second figure explains the refraction of a light. Okay, so what is mean by reflection of a light? For that purpose, let us consider the plane reflecting surface xy. Draw a normal n dash to the surface. Okay, now this PO is the incident light ray. This incident light ray makes an angle of I, okay, which is called as angle of incidence. Now when PO is incident on the surface xy, it moves back into the same medium, and this phenomenon is called as reflection of a light. And this light ray OQ is called as reflected light ray. And the angle between the reflected light ray and the normal is called as angle of reflection. And also we know that the three different laws of reflection. The first law of reflection says that the angle of incidence is equal to angle of reflection. The second law of reflection is the incident ray and the reflected ray lie on the opposite sides of the normal. And the third law is the incident ray, reflected ray and the normal all lie in the same plane. Okay, now we are moving towards the refraction of a light. So for the refraction of a light, minimum two mediums are necessary. Here we are considering the refracting surface xy, which separates the two medium, rarer medium and denser medium. Now again, this n dash is the normal which is drawn to the surface xy. Now consider the incident light ray PO, which is incident at point O on the surface xy. Again, this I is nothing but the angle of incidence in the rarer medium. So when this PO, incident light ray, is incident on the refracting surface XY. Partial refraction and partial reflection takes place. But here reflection is not shown in the figure. So this angle is called as angle of refraction. When light ray moves from rarer medium to denser medium, then the refracted ray bends towards the normal. So here angle of incidence is greater than that of the angle of refraction. Again, there are three different laws of refraction. The very first law, which is very important, named as Snell's law. And Snell's law states that mu12 is equal to C1 upon C2 is equal to lambda 1 upon lambda 2 is equal to mu2 upon mu1, or we can define this refractive index in another way. Real depth upon apparent depth is equal to sin I upon sin R, which is the Snell's law, and this mu12 is also equal to 1 upon sin IC, where IC is the critical angle. And in this chapter we are going to consider, or we are going to study the relation mu12 is equal to tan IP, and IP stands for the polarizing angle. Okay, here C1 means the velocity of light in the first medium, and C2 is the velocity of light in the second medium. Similarly, lambda 1 means the wavelength of the light in the first medium, and lambda 2 is nothing but the wavelength of the light into the second medium. Okay, mu2 means the refractive index of the second medium, and mu1 means refractive index of the first medium. Okay, this is the introductory part only. Now the topic starts from the article nature of a light. Okay, actually nowadays we assume that the light has dual nature, particle nature as well as wave nature. But the very first theory, which is proposed by the scientist Sir Isaac Newton in 1675 in order to explain the nature of a light, and that theory is termed as Newton's corpuscular theory. Corpuscles means the tiny particles which are rigid, elastic and massless spheres. Okay, when the corpuscle strikes a reflecting surface, they undergo elastic collisions. You have already studied the elastic collisions in the 11th standard. Actually, there are three different types of collisions: elastic collision, inelastic collision, and partially elastic and partially inelastic collision. So when light corpuscles strikes a reflecting surface, they undergo elastic collisions. Okay, corpuscles travels at a very high speed in straight lines in a given medium. This is the very important success point of this theory, because Newton proposed that light propagates along the linear path, or there is a rectilinear propagation of the light. Okay, again Newton proposed that the different colors of the light are due to the different sizes and shapes of the corpuscles. Okay, these are the assumptions of the Newton's corpuscular theory, but Newton's corpuscular theory was discarded because it is suffered from number of drawbacks, such as Newton predicted that the speed of light in air medium is less than that of the speed of light in a denser medium. But nowadays we know that the speed of light in rarer medium is greater than that of the speed of light in the denser medium, and this is the most important drawback of this Newton's corpuscular theory. Okay, again Newton's corpuscular theory failed to explain the phenomenon of interference and diffraction, because in order to explain these phenomena like interference and diffraction, we require the wave nature of a light. But Newton proposed the corpuscular, means particle nature of a light. Okay, again this theory could not satisfactorily explain the phenomenon of polarization and the simultaneous reflection and refraction. So finally, with these drawbacks, this theory was discarded and the new theory came up, which is called as Huygens wave theory of light. And in this chapter, we shall briefly discuss this theory. ही जी थिअरी आहे याच्यावरती आपला निम्मा चॅप्टर जो आहे तो बेस्ड आहे की जी आपल्याला ही थिअरी स्टडी करायची आहे. ओके, नाव लेट अस कन्सिडर the assumptions of the Huygens wave theory of a light. Huygens proposed that light propagates in the form of waves and those waves are longitudinal in nature. Okay, again this is the important drawback of this theory because nowadays we know that light is a transverse electromagnetic wave. But Huygens proposed that light is a longitudinal wave. मग वेगवेगळ्या सायंटिस्टनं असा प्रश्न विचारला की जर लाईटचं लॉन्जिट्यूडनल वेव्ह नेचर असेल तर मग सनपासून येणारे लाईट रेज अर्थपर्यंत कसे येतात, बिकॉज देर इज नो एनी मीडियम बिटवीन दी सन अँड दी अर्थ बिकॉज देर इज अ वॅक्यूम. सो इन ऑर्डर टू एक्सप्लेन दिस, Huygens proposed that there is a medium which is called as luminiferous ether and this medium is present everywhere. आणि त्याच्यानंतर हे प्रूफ झालं की luminiferous ether medium is an hypothetical medium which do not have the real existence. So this is the important drawback of this theory. Again, Huygens proposed that light waves are emitted from the source of light and they move with the constant speed in the homogeneous medium. Homogeneous means in the same medium. Okay, now when these light waves enter our eyes, we get the sensation of the light. Okay, and the different colors of the light are due to the different wavelengths of the light waves. These are the assumptions of the theory. Now we are moving towards the successes and failures of this theory. Okay, first of all, the success points. The first success point is with the help of Huygens wave theory of light, the different phenomena of light like reflection, refraction and interference can be successfully explained. The second one is we can easily explain the simultaneous reflection and refraction of the light wave. And the very important merit point of this theory is that Huygens proposed that the velocity of light in rarer medium is greater than that of the velocity of light in denser medium, and nowadays this is accepted. Okay, along with these merit points, the theory had some drawbacks as well. So the first drawback is Huygens assumed the presence of luminiferous ether medium, but experimentally it was proved wrong. Second is the rectilinear propagation of light, means the linear straight line path of the light ray cannot be explained with the help of the wave theory of light. Okay, again Huygens assumed that the longitudinal wave nature of a light, but we know that the light has a transverse electromagnetic wave nature. Okay, so now the third theory is Max Planck's quantum theory of light. Max Planck's quantum theory is related to the photon nature of light. According to Max Planck, light propagates in the form of quanta, means in the form of photons, and each photon has energy equals to h nu. Okay, now the next theory is Maxwell's electromagnetic wave theory of light. This theory you have already studied in the 11th standard under the chapter Electromagnetic Waves. According to Maxwell, light propagates in the form of time varying electric and magnetic fields. The electric and magnetic fields both are perpendicular to each other, and as well as they are perpendicular to the direction of propagation of a light. And finally, we are accepted the dual nature of a light, means particle nature as well as wave nature. So on this point, we conclude our lecture and we'll see into the next lecture. Thank you.